everyone, thank you so much for joining this video. Here are today's learning objectives. So the first is to know that transition metals form coloured ions in solution. The second is to understand that the colour of aqueous ions and other complex ions results from the splitting of the energy levels of the d orbitals by ligands, and to understand why there is a lack of colour in some aqueous ions and other complex ions. And then our last learning objective will be to understand that colour changes in transition metal ions may arise as a result of changes in oxidation number, ligand, and coordination number. Now we're going to talk about the formation of coloured ions. So transition metal compounds are coloured because they have part-filled d orbitals. And this means that electrons can move from one d orbital to another. And so in a compound, the presence of other atoms means that the d orbitals have slightly different energies. So when electrons are excited, they move from a d orbital with lower energy, which we call the ground state, to a d orbital with a higher energy, which we call the excited state. And so they absorb the energy in the spectrum, in the visible spectrum, equal to the difference in energy between these two levels. And so we see the combination of colours which are not absorbed. And the remaining wavelengths of light are either transmitted or reflected. So if we're talking about solutions, then we say transmitted. But if we're talking about solids, we say reflected. And these two terms can't be swapped around. So examples of ions which aren't coloured are scandium. So the ion of scandium is scandium 3+, but it hasn't got any d electrons left to move around, and so there's not an energy transfer equal to that of visible light when it gets excited, so therefore it has no colour. For zinc and copper ions, we have a similar thing. So their d shells are full, and so there's no space for electrons to transfer, and therefore there is not an energy transfer equal to that of visible light, and so they have no colour either. A change in colour can be due to either a change in oxidation number of the metal, different ligands. So if we go through a ligand substitution, we might end up with a complex with a different colour compared to the complex that we started with, and also a change in coordination number. So again, that can come from ligand substitution. Changing any of these things alters the energy difference between the ground level state and the excited level state. So a different wavelength of light is absorbed. So the important thing to remember is that the energy difference will be a different wavelength of light absorbed. And the absorption of visible light is actually used in spectroscopy, where a colorimeter is used with a suitable calibration graph to measure the concentration of solutions of coloured transition metal compounds. And the more concentrated a solution is, the less light it transmits. And we use transmits here because we're talking about solutions. So now we're going to look at some questions. So for 1A, explain why transition metal complexes are coloured. So this is a really important question because it'll come up quite a lot, and you really need to know why it is. And it's because all the d orbitals have different energies. And so that means that when electrons become excited, they can move between these d orbitals. And so when they get excited, they move to a higher energy level, which is called the excited state. And when they move back down again, as they're unstable there, when they move back down again to the ground level state, so now we're going to look at some questions. For 1A, explain why transition metal complexes are coloured. So the reason why is because when we excite electrons, especially. So now we're going to look at some questions. For 1A, explain why transition metal complexes are coloured. Transition metal complexes are coloured because they have those part-filled d orbitals, and this means that because the d orbitals all have slightly different energies, when we excite electrons, they move up to a higher energy level state, and we call this the excited state, compared to where they were originally called the ground state. And the difference in energy is actually given out as light energy, and so this is why they are coloured, because they're given out as light energy. They are absorbed So now we're going to look at some questions. For 1A, explain why transition metal complexes are coloured. So this is a really key thing that you need to remember. So why they're coloured is because in transition metal compounds, the 5d orbitals do not all have the same energy. And so when we excite electrons, they absorb visible light to provide energy for themselves to move to a higher energy level. And this is called the higher level state compared to where they were before, which is the ground level state. And the energy difference between these two levels corresponds to a wavelength or a frequency of light energy. And so when we see colour, we are seeing the wavelengths of light that have not been absorbed. So the first point is that the d orbitals do not have the same energy. And then when electrons are excited, they absorb energy to move to a higher energy level. And the electrons can move around because, first of all, in transition metals, they have only part-filled d orbitals. And this is called the excited level state from the original level, which is the ground level state. And then what we have is that the difference in energy between these two levels is equal to a particular wavelength or frequency, you could say, of visible light. And so that means that we see the light which isn't absorbed. And it's also really important to remember the difference between reflects. So when we're talking about solids, we say reflects. So when a solid looks yellow, we say it reflects yellow. However, if it's a solution, we say transmits. So if we have a yellow solution, we say yellow is transmitted. So for B, identify 4 factors that affect the colour of transition metal complexes and explain why these changes affect the colour. So 4 changes. So the first is the different oxidation state of metal. And then secondly, we have different ligands. We can also say if we have a different metal altogether. And the last one is a different coordination number. And the reason why the colour changes when we change either one of these is because the energy, so the difference between the two energy levels, has been changed. And so the wavelength of light which has been absorbed has also changed. So we see different colours. So the difference between energy levels has changed. And this means that different wavelengths of light absorbed, and this leads to a different colour seen.